Welcome everybody to what will be a fantastic video about using the chain rule. Here we have y equals x cubed plus 1 and all of that is squared. If we were trying to work out its derivative, then what we'd have to do is expand that bracket out. And so we get a sequence of terms and then differentiate each term. Now that would take a little bit of work, but it'd be quite manageable. However, if we consider y equals x cubed plus 1 raised to the power of 30, expanding this out would be a massive task. Fortunately, there's a technique that can help us differentiate these kind of expressions, and that technique is known as the chain rule. When we consider y equals x cubed plus 1 all squared, we see this as being a composition of two functions. Firstly, you've got the function u inside the brackets, and u is equal to x cubed plus 1. So that's one function. The second function is taking the u, what is in the brackets, and squaring it. So I see y as being equal to u squared, where u is just the content of what's inside the brackets, and u itself is equal to x cubed plus 1. So the x cubed plus 1 is here, and then I've got that u, which is the bracket, and I'll square it. When we have expressions like this, compositions, then what we can do is apply the chain rule. So dy dx will equal dy du multiplied by du dx. And this becomes more obvious in the example below. So here we have y equaling x cubed plus 1 all squared. I make the content of the brackets equal to u, so u is equal to x cubed plus 1. I then find the derivative of that, so I work out du dx. So obviously it just becomes 3x squared. I write y, but I write it in terms of u. So y is going to equal the content of the brackets all squared. So y is going to equal u squared. The derivative of that is 2u. Notice that I've got du dx, so change in u with respect to change in x is 3x squared. And here I have dy du. Change in y with respect to u is 2u. I now write down the chain rule, so dy dx equals dy du multiplied by du dx. Dy du was equal to 2u. Du dx was equal to 3x squared. Now we want to have an answer in terms of just x, not u. And I can go back and substitute what u was equal to. U was equal to x cubed plus 1. So I've subbed that in the next line of workings here. And then finally I've tidied it up. So that there is the chain rule. Now that can take us a fair bit of time to work out using the chain rule. And fortunately, there's a shortcut. So if I have y equaling some function of x raised to the power of n, then dy dx is equal to this. The power comes down. I take the derivative of f of x. I multiply it by the original function, f of x inside here, and raise that to 1 less of what the previous power was, so just n minus 1. Let's look at that in some problems. So firstly, I have a. So y equals x squared, take 2x raised to the power of 3. The power comes down. I take the derivative of what's inside the bracket, so x squared is the 2x, negative 2x becomes negative 2 when we differentiate. I take my original bracket and raise it to the power of 1 less than what it was previously. In my next line of workings, I realize that a 2 is a common factor. So we end up with this 6 lots of x minus 1 multiplied by x squared, take 2x raised to the power of 2. In B, I've got y equals x cubed plus 2x squared raised to the power of negative 5. Same process. The negative 5 comes down. I take the derivative of what's inside the bracket. I take that bracket again and subtract 1 away from the power. So negative 5 taking away 1 becomes negative 6. I realise that this to the power of negative 6 can be brought to the bottom of the fraction and expressed as a positive power. So just taking that bracket there, put it to the bottom and put it as positive 6. C. I've got f of x equaling the square root of x squared take 3x plus 7. My first job is to rearrange this so it's in a format that I recognise. So instead of having the square root, I'm going to put in a bracket and then raise it to the power of a half. I now apply the shortcut to the chain rule, so the power comes down. I take the derivative of what's inside the bracket, so it becomes 2x take away 3. I have my original bracket, and I subtract 1 from it. So a half take away 1 will be negative a half. Fractions, so writing in fractional format, I've got a half here, so I'm going to put the something over 2 there to begin with. 2x minus 3, that goes up the top. And because I've got multiplying by this to the power of negative a half, I'm going to take that to the bottom and express it as a positive power. Finally, I realise that anything raised to the power of a half is the same thing as taking the square root of it. So I take the content of that bracket and put it within the square root symbol. So I've got 2x minus 3 over 2 lots of the square root of x squared take 3x plus 7. So now obviously that first example which you saw where we had a bracket raised to the power of 30 could be handled quite easily.